Number 9 is on molecular orbital theory, which you learned for the first exam. Now, the wording of this question is a little bad, honestly. It says, which pair of orbitals represents the possible HOMO-LUMO interaction in a Diels-Alder reaction? And so, they didn't really give you the structures you're supposed to work with, but what they assumed you to know is that for your generic Diels-Alder, you just have a diene and a dienophile, and that's really what they wanted you to work with. Draw the orbital diagrams for these two and figure out whose HOMO and whose LUMO matches up with your answer choices. So let's start with the diene. The diene has 1, 2, 3, 4 carbons, so I'm going to draw 4 energy levels, 1 for each carbon. And I'm going to number that 0, 1, 2, and 3. And what these numbers represent are your nodes, and we'll explain what nodes mean in a second. Now I'm going to count how many pi electrons are in the system. Now pi electrons come from 3 things: double bonds, lone pairs, and negative charges. Well, there are no lone pairs or negative charges, so there are just double bonds. And each of those things are worth 2 electrons. So since I have 2 double bonds, I have 2 4 pi electrons total. 4 pi electrons. And I might as well count these as well. This has 2 pi electrons because it's only got 1 double bond, so 2 pi electrons. But we don't really need to work with this yet, so let's just focus on the diene. So now, for every pi electron you have, you're going to start filling in your energy levels. You always start at the bottom, and each energy level fits 2 electrons. 1 up arrow and 1 down arrow is how we represent it. So that's 2 electrons, and I still have 2 more to go, so I go to the next energy level and do that. So this is going to be the energy diagram associated with the pi electrons of my diene. Now the next thing I have to do is identify which energy level corresponds to my HOMO and which corresponds to my LUMO. Well, HOMO stands for the highest occupied molecular orbital, the highest energy level that has electrons. So 1 is my HOMO. LUMO stands for the lowest unoccupied molecular orbital, or the lowest energy level that does not have electrons, which in this case must be this one. So I have my HOMO and my LUMO drawn out. Now I'm going to pause here and I'm going to do this, the dienophiles now. So in this example in this structure I have 2 carbons, which means 2 individual energy levels, and I have 2 pi electrons, which means 1, 2, and then I just number 0 and 1. Okay, and so this must be my HOMO here, my highest occupied molecular orbital, and then this must be my LUMO because it is my lowest unoccupied molecular orbital. Now the rule about HOMO-LUMO interactions for a diene and a dienophile in any Diels-Alder is that the HOMO of the diene interacts with the LUMO of the dienophile. So now that I've drawn out my energy diagrams, I have to start drawing the orbital diagrams. And so what that translates into is, let's start with the diene again. So I want to draw my HOMO of the diene. So start by just drawing however many carbons were in the chain. The diene had 4 carbons, so 1, 2, 3, 4. I'm just going to draw a 4-carbon chain with nothing special. Now I'm going to draw some 8s on it, because these 8s represent each individual orbital that is involved in the pi system. Now this is on the level that has 1 node. And what a node is where you can draw a dotted line through the structure and have an equal number of orbitals on either side. Since there's only 1 node, that means I have to draw that dotted line down the center. Now you're going to start coloring in the orbitals. Now pick one side of your orbital and start coloring it in. So let's say I want to color in the top half. And you're just going to keep coloring in the top half of every orbital until you reach a node. When you hit that node, you flip the side that you color in. So if I was coloring in the top to begin with, now I'm coloring in the bottom. And since there are no other nodes, I only flip the color once. Now I have to draw the LUMO of my dienophile. So there were only 2 carbons, so I draw a 2-carbon chain. And on each carbon, I draw an 8. Now again, the LUMO had 1 node based on this, and that means I need to draw a dotted line down the center, because that is where I would draw a dotted line to have an equal number of orbitals on either side. And again, I'm just going to start by coloring in one side, and then when I hit the node, color in the opposite. And so this would be the orbital diagram of my diene, and this would be the orbital diagram of my LUMO of my Dionophyll. And this matches up, so the Dionophyll's matches up with choice 2 on the answer key, and the Dionophyll's matches up with choice 6 on the Dionophyll. So 6 and 2 are your answer, which was choice F.